Just a few drops of lemon juice can dull the surface of a polished marble countertop. Yet, this seemingly delicate stone has endured in monuments, palaces, and cathedrals for hundreds, even thousands of years. But turning part of a mountain into a gleaming stone slab is not as simple as breaking the rock apart and hauling it away. A single crack running in the wrong direction can strip most of the value from a marble block weighing hundreds of tons. That is why the process must unfold like surgery. From controlled blasting and diamond wire cutting, to block splitting, slab cutting, polishing, and CNC finishing. Join Factron Process inside the quarry, where every drill hole, cutting pass, and block lowering operation must be executed with precision. And discover how workers separate part of a mountain and transform it into marble slabs worth tens of thousands of dollars. Today, marble is part of a global natural stone industry worth billions of dollars each year. In the United States alone, producers sold or used roughly 2.5 million short tons of dimension stone in 2025, valued at about $460 million. What makes marble unusual is that a block is not valued by weight alone. Its true worth depends on its color, veining, size, and the number of intact slabs that can be recovered from within. A single crack running in the wrong direction can turn stone intended for a high-end project into smaller pieces worth far less. That is why factories do more than simply sell stone. They transform imperfect natural blocks into premium architectural materials, where every precise cut can preserve or destroy thousands of dollars in value. The value of a marble block weighing hundreds of tons can be decided before the cutting machines even start. First, geologists must read the mountainside, identifying its base color, the direction of its veining, and hidden fractures that could ruin the entire block. Exploratory drills penetrate deep into the mountain to extract core samples, while measuring instruments and geological maps help reconstruct the structure beneath the surface. Using this data, the quarry team determines where to open the next bench, position the machinery, build the haul roads, and orient the cuts to recover the greatest number of intact slabs. Finally, the planned cutting lines are marked directly onto the quarry face. Because in this industry, the goal is not simply to extract the largest block, it is to find the largest block capable of surviving every stage that follows. Once the extraction zone has been identified, crawler drills move into the overburden and the outer layers of non-commercial rock, boring a precise pattern of vertical or angled holes. Industrial explosives are loaded into each hole and detonated milliseconds apart, forcing the unwanted rock to fracture in sequence rather than shatter uncontrollably. The blast is not meant to break the valuable marble. Its purpose is to strip away the outer rock, expand the working area, and form the quarry's stepped benches. Excavators then clear the bench face, bulldozers level the ground, and haul trucks carry away the debris. Once the commercial marble is exposed, the blasting stops, and precision cutting takes over. How can a wire barely an eighth of an inch thick separate an entire section of a mountain? Once blasting has opened the quarry bench and exposed the valuable marble, brute force gives way to the diamond wire saw. A seemingly simple tool that operates with the precision of surgical equipment. First, vertical and horizontal boreholes must intersect perfectly inside the rock, creating a continuous passage through dozens of feet of marble. A thin pilot line is threaded through these holes to pull the diamond wire into position. Its two ends are then joined into a continuous loop and tensioned around a system of guide pulleys. When the motor starts, hundreds of industrial diamond beads race across the stone at speeds approaching 100 miles per hour. They do not slice through the marble like conventional saw teeth. Instead, they grind away the material layer by layer, creating a narrow, flat cut with almost no vibration. The machine slowly retreats along its rails to maintain steady tension, while water continuously cools the wire, suppresses dust, and flushes stone slurry from the cut. After hours of cutting the vertical face, rear face, and base, an enormous marble block is finally separated from the mountain. But the most dangerous challenge still lies ahead. Lowering it without allowing its own weight to destroy the veins worth thousands of dollars inside. When the final cut is complete, the marble block still stands against the quarry face as though it remains part of the mountain. Workers insert hydraulic bags or splitting wedges into the cut, then slowly increase the pressure, widening the gap inch by inch. Excavators, steel cables, and anchoring systems guide the block's movement, while a prepared cushioning bed below is positioned to absorb the impact. At this stage, a single block can stand more than 20 feet tall and weigh hundreds of tons. So operators never pull it free with one sudden force. Instead, they make the stone move in controlled stages, tilt at the correct angle, and leave the wall without escaping their control. One moment of imbalance could shatter marble veining worth thousands of dollars into rubble. Once it leaves the quarry face, the marble is still not ready to enter the factory. It remains an enormous rough block with uneven edges, irregular surfaces, and weak zones hidden beneath a layer of white dust. Before cutting begins, technicians wash each face, trace the newly exposed fractures, and mark exactly which sections must be removed to protect the valuable core. A wheel loader rotates the block into position. Then a diamond wire saw or quarry chainsaw begins trimming away the excess stone, one edge at a time. Water flows continuously into the cut, cooling the equipment and carrying the stone slurry away. With every pass, the rough mass is gradually shaped into a nearly rectangular block in a process known as squaring. These new flat surfaces do more than keep the block stable on a haul truck. They also reduce it to the exact length, width, and height that the factory's cranes, cutting beds, and saws can safely handle. Every cut is an economic decision. Remove too little, and a dangerous defect may remain inside. Cut too deeply, and tons of valuable marble disappear. So, if the choice were yours, would you keep a few extra tons, or sacrifice the excess to protect the finest stone within? Once the marble block has been squared, the next challenge is moving dozens, sometimes hundreds of tons of stone out of the quarry without damaging it. The operator lifts the load slowly, keeping the block as close to the machine as possible, so its center of gravity remains within a safe range. For blocks that are difficult to rotate, a crane or second excavator helps adjust the position inch by inch. The marble is then lowered onto a heavy-duty haul truck, resting on wooden beams or reinforced supports that distribute its enormous weight and prevent direct contact with the steel bed. Chains, wedges, and restraints lock the block in place, because even a small shift during braking or cornering can drive a hairline fracture deeper into the stone. The truck moves at low speed along steep quarry roads, winding past narrow turns and exposed bench edges. Every acceleration, brake application, and steering adjustment must remain smooth. The block does not need to fall from the truck to be ruined. A single violent impact against the support frame may be enough to damage the valuable structure inside. And only when the block is opened inside the factory will its true veining and its real value finally be revealed. When the marble block arrives at the factory, a crane lowers it into the inspection area. High-pressure water jets strip away mud, drilling dust, and stone slurry, revealing the base color, mineral veins, and defects across the surface. Technicians record every dimension, mark visible flaws, and assign the block an identification code, so each finished slab can later be traced back to its original quarry and extraction bench. Then comes the most important decision: how the block should be oriented before sawing. Cutting along the veining can produce long, dramatic bands, while cutting across the same structure may transform it into clouds, waves, or scattered patterns. This is the moment when the factory decides how to open the stone, balancing material recovery with the greatest possible visual impact. After squaring, the marble block is locked onto a heavy-duty cutting trolley and slowly guided into the multiwire saw, a machine designed to transform one massive solid block into dozens of precision-cut slabs. Above the stone, multiple loops of diamond wire are tensioned into nearly perfect parallel lines. When the motor starts, the entire wire assembly begins to descend. Hundreds of industrial diamond beads race across the surface, grinding through the marble layer by layer. Unlike a conventional saw that produces only one slab at a time, this system opens multiple parallel cuts simultaneously. as if the machine were slicing an enormous loaf of stone in one precisely controlled motion. The wires are extremely thin, and that is their greatest advantage. The narrower the cut, the less marble is lost as stone powder, allowing more valuable surface area to be recovered from the original block. Water pours continuously through the cutting zone, cooling the wires, suppressing dust, and carrying the stone slurry away. The cloudy water is then collected, filtered, and often pumped back into the production line, while the separated stone residue is removed. After hours of continuous cutting, the once solid block has been divided into a row of slender slabs. Then the first slab is lifted away, and for the first time, the colors, mineral clouds, and veins that had slept deep inside the mountain are revealed across the entire surface. After leaving the multiwire saw, each marble slab still carries wire-cut marks, slight surface irregularities, and natural defects that may remain almost invisible to the naked eye. Diamond grinding heads sweep across the stone, leveling the outer surface and creating the precise texture needed for the reinforcement materials applied next. Under powerful inspection lights, pores, hairline fractures, and unstable areas begin to reveal themselves. In marble, some of the most dramatic veins can also run through the weakest parts of the slab. Workers carefully mark each defect before epoxy resin is poured and spread across the entire surface. Rollers or squeegees force the liquid resin deep into even the smallest openings. As it hardens, the epoxy forms an almost invisible bonding network, locking separate mineral sections together, so the slab behaves more like one solid structure. For thinner slabs or marble with dense, complex veining, fiberglass mesh is also bonded to the back. This reinforcing layer distributes bending stress and helps stop fractures from spreading when the slab is lifted, transported, or cut into precise architectural components. Finally, the slab enters a curing chamber, where controlled heat and time allow the resin to harden completely. The epoxy does not erase the marble's natural character. Instead, it gives this inherently fragile stone the strength to survive the demanding stages ahead, from high-speed polishing and CNC machining to transportation and final installation. The technical drawing is converted into digital coordinates and loaded into a bridge saw or CNC machining center. A vacuum lifter places the marble slab onto the cutting table, where it is aligned to reference points and secured with suction cups and mechanical stops. Once the program begins, the diamond blade follows its programmed path, automatically rotating and tilting to divide the large slab into countertops, stair treads, wall panels, or other precisely sized components. Water sprays continuously across the cutting zone, cooling the blade, suppressing dust, and flushing away stone slurry. After the main cuts are complete, diamond milling tools take over the more complex work. They open sink cutouts, carve cooktop recesses, round corners, and form curves that a straight saw blade cannot produce. The machining sequence must be carefully planned. Narrow strips and internal corners are often left until the final stages, allowing the surrounding stone to support them for as long as possible. In vulnerable areas, the machine may also cut grooves into the underside, so reinforcing rods can be installed before the piece is lifted from the table. Finally, edge polishing heads travel around the perimeter, producing straight, beveled, or decorative profiles. Workers finish the areas the machine cannot easily reach and test fit-related sections. From this point forward, the marble is no longer a standard slab. It has become a precision-made component designed for one specific place in a building. Before any marble component leaves the factory, it must pass one final test. Technicians measure its dimensions, check the flatness and surface gloss, and run their hands along every edge for chips or irregularities. Sink openings, joints, and cut lines are compared with the original technical drawings, while repaired areas are examined under angled light to reveal trapped air, raised resin, or defects that would disappear under normal illumination. Once approved, the stone is cleaned and may receive a penetrating sealer. This treatment cannot make marble completely stain-proof, but it slows liquids from entering the stone's microscopic pores, giving the surface more time to be cleaned before damage occurs. Protective film is applied across polished faces, while foam pads and edge guards shield the most vulnerable corners. Large pieces are stored almost upright, then loaded onto steel A-frames and secured with heavy straps so they cannot shift during braking or sharp turns. At the construction site, vacuum lifters and specialized clamps raise each piece into position. Only when the final slab becomes a countertop, floor, staircase, or wall does a journey that began inside a mountain finally reach its destination. Marble is not created in a factory. The factory only cuts, stabilizes, and reveals a structure that nature formed long ago. From the controlled blast that opens the quarry bench, the boreholes that guide the wire, and the diamond cuts through the mountainside, to multiwire sawing, epoxy reinforcement, polishing, and CNC machining, every stage serves one goal: recovering the largest possible area of intact stone from a resource that cannot be quickly replaced. A mild acid can dull its surface. Yet when marble is carefully selected, properly processed, and correctly maintained, it can endure for generations. Which part impressed you most? The moment a massive block was lowered from the mountain, the multi-wire saw, or the polishing line? Leave your answer in the comments, hit the like button, and subscribe to Factron Process as we continue exploring more extraordinary industrial processes.